Hello viewers, welcome to my channel and thank you for watching and subscribing the channel. इस वीडियो में हम नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशन ऑफ ऑर्डर 1 के स्पेशल केसेस को करेंगे। अभी तक हमने कंप्लीट इंटीग्रल, सिंगुलर इंटीग्रल, जनरल सॉल्यूशन, पर्टिकुलर इंटीग्रल, कॉम्पेटिबिलिटी ऑफ इक्वेशंस एंड चारपिट्स मेथड कवर कर लिया है। चारपिट्स मेथड जो है एक जनरल मेथड है टू सॉल्व नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशन ऑफ ऑर्डर 1। कुछ इक्वेशंस वी कैन रिड्यूस देम टू स्टैंडर्ड फॉर्म और उनका कंप्लीट इंटीग्रल बाय इंस्पेक्शन या किसी अदर शॉर्टर मेथड से फाइंड आउट किया जा सकता है इंस्टेड ऑफ चारपिट्स मेथड। चारपिट्स मेथड वी अप्लाई करते हैं जब क्वेश्चन में लिखा हो use Charpit's method or we cannot reduce the equation into the standard form, one of the standard forms। 4 standard form है। पहली standard form है जबकि P and Q present है and P and Q occur other than in first degree, that is non-linear equation। So special cases special methods of solutions applicable to certain स्टैंडर्ड फॉर्म्स। सो पहला है P एंड Q अकर। तो कंडीशन है P एंड Q अकर अदर देन इन द फर्स्ट डिग्री। दैट इज नॉन-लीनियर इक्वेशन। स्टैंडर्ड फॉर्म लेते हैं 1 only P and Q are present so this is the case। अगर हम इस फॉर्म में या अदर 3 फॉर्म्स जो और हैं इनमें से किसी भी फॉर्म में हम रिड्यूस कर लेते हैं इक्वेशन को और उन्हें बाय इंस्पेक्शन या किसी शॉर्टर मेथड से सॉल्व कर सकते हैं, तो चारपिट्स मेथड अप्लाई करने की रिक्वायरमेंट नहीं है। पर अगर क्वेश्चन में लिखा है अप्लाई चारपिट्स मेथड देन यूज दैट मेथड ओनली, क्योंकि वो जनरल मेथड भी है। इक्वेशन कैन बी रिटन लाइक दिस FPQ is equal to 0, क्योंकि जनरली FXYZ PQ is equal to 0 होती है, XYZ प्रेजेंट नहीं है। सो दिस इज इक्वेशन 1। अब हम चारपिट्स ऑक्सिलरी इक्वेशन लिखें। सो dP अपॉन FX प्लस PFZ is equal to dQ अपॉन Fy प्लस Q Fz। अब जैसे कि x, y और z के टर्म्स नहीं है तो ये टर्म्स जो डिनोमिनेटर में ये 0 होंगी। सो दिस विल रिड्यूस इनटू dP अपॉन 0 इज इक्वल टू dQ अपॉन 0। जो रिमेनिंग टर्म्स हैं वो यहाँ पर एग्जिस्ट करेंगी। dz अपॉन माइनस P dP माइनस Q FQ इज इक्वल टू dx अपॉन माइनस FP इज इक्वल टू dy अपॉन माइनस FQ। सो हम यहाँ से फाइंड आउट करते हैं दैट dP इज 0 एंड dQ इज 0। इंटीग्रेट कर लेते हैं तो हमें वैल्यू मिल जाएगी P इज इक्वल टू A एंड Q इज इक्वल टू, ये कॉन्स्टेंट्स हैं, जहाँ की बी इस फॉर्म का है कि एफ ए बी इज इक्वल टू 0। सो डी जेड में हमने पी एंड क्यू की वैल्यू सब्सटीट्यूट कर दी। पी इज ए एंड क्यू इज बी। इंटीग्रेट कर लिया, z इज इक्वल टू ए एक्स प्लस बी वाई प्लस सी। सी आर्बिट्रेरी कांस्टेंट है। तो ये सॉल्यूशन हो गया। अब हम मार्क कर लेते हैं इक्वेशंस को। दिस इज 2, दिस इज 3, देन 4 एंड 5। इसका मतलब z इज इक्वल टू ए एक्स प्लस बी वाई प्लस सी एंड एफ ए बी इज इक्वल टू 0। दैट इज इक्वेशन 5 एंड 4। ये मिला करके हमें रिक्वायर्ड सॉल्यूशन दे देते हैं। गिव द रिक्वायर्ड सॉल्यूशन। अब जैसे कि हमें पता है z इज इक्वल टू ए एक्स प्लस बी वाई प्लस सी, और हमने माना है b इज इक्वल टू फंक्शन ऑफ a। तो हम ये वैल्यू अगर सब्सटीट्यूट करते हैं, z इज इक्वल टू ए एक्स प्लस एफ ए वाई प्लस सी। अब इस इक्वेशन में a और c दो आर्बिट्रेरी कांस्टेंट्स हैं एंड दो ही इंडिपेंडेंट वेरिएबल्स हैं। 2 इंडिपेंडेंट वेरिएबल्स एंड नंबर ऑफ आर्बिट्रेरी कांस्टेंट्स इज इक्वल टू नंबर ऑफ आर्बिट्रेरी इंडिपेंडेंट वेरिएबल्स। इसका मतलब ये कंप्लीट इंटीग्रल है। अब हमें फाइंड आउट करना है सिंगुलर इंटीग्रल देन जनरल इंटीग्रल। सिंगुलर इंटीग्रल इज z इज इक्वल टू ए एक्स प्लस एफ ए वाई प्लस सी है। हम इसे पार्शली डिफरेंशिएट करते हैं विद रिस्पेक्ट टू द कांस्टेंट्स। यहाँ क्या है, a एंड c। सो डेल z अपॉन डेल a is equal to 0 is equal to x. This implies 0 is equal to x plus y f dash a, and del z upon del c, this gives 0 is equal to 1, क्योंकि z का a के रेस्पेक्ट में और c के रेस्पेक्ट में 0 है एंड राइट हैंड साइड में c का 1 हो गया। And this is meaningless equation. It means no singular integral exists. No singular integral is there. Now general integral, हम substitute करते हैं c is equal to phi a। phi जो है arbitrary function है, तो z इज इक्वल टू ए एक्स प्लस वाई एफ ए प्लस फाई ए एंड दिस गिव्स 0। यहाँ भी हम a के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं, इज इक्वल टू एक्स प्लस वाई एफ डैश ए प्लस फाई डैश ए। अगर हम ये z इज इक्वल टू दिस इक्वेशन लेट से a एंड दिस इक्वेशन इज b, इन दोनों में से अगर हम a को एलिमिनेट कर दें, देन वी विल गेट जनरल सॉल्यूशन ऑफ गिवन इक्वेशन, दैट इज एफ पी क्यू इज इक्वल टू 0। सो एलिमिनेट a between equations a and b, and we get the general solution of equation fpq is equal to 0. Note है, in some situations we can apply change of variables. चेंज ऑफ वेरिएबल्स हम अप्लाई करके इक्वेशन को ट्रांसफॉर्म कर देते हैं। So given equation transform to this standard form 1 और फिर हम उसे सॉल्व कर सकते हैं. नाउ वी डू 2 examples based on it. We do examples based on it and past year papers questions also. So first question is PQ is equal to K. Solve this equation. So this is the form FPQ is equal to 0. अगर ये फॉर्म है तो हमें पता है इसका सॉल्यूशन क्या है. Z is equal to AX plus BY plus C. अगर हम P की जगह A, Q की जगह B सब्सटीट्यूट कर दें तो ये हो जाएगा AB is equal to K. We can say FAB. यहाँ से हम B निकाल सकते हैं K अपॉन A. तो B क्या हो गया, फंक्शन ऑफ A के फॉर्म का ऑब्टेन हो गया. यहाँ रिप्लेस किया है P को एंड दिस इज Q. नाउ वी पुट वैल्यू ऑफ B इन Z. AX प्लस FAY प्लस C. अब हम देखते हैं कि इसमें 2 आर्बिट्रेरी कांस्टेंट्स हैं. 2 आर्बिट्रेरी कांस्टेंट्स A and C and 2 independent variables X and Y. So ये Z जो ये इक्वेशन हमें मिली है, this is 1. Equation 1 is complete integral of the given equation. अब हमें सिंगुलर इंटीग्रल निकालना है और जनरल इंटीग्रल फाइंड आउट करना है. So for singular integral जो आंसर है उसे हम, जो कंप्लीट इंटीग्रल है उसे हम पार्शियली डिफरेंट करेंगे विद रिस्पेक्ट टू कांस्टेंट्स A and C respectively. So Z is equal to AX plus K upon A Y plus C. This is complete integral also. So differentiate it with respect to A and C. And क्योंकि जब भी हम differentiate करेंगे वो partially होगा, so you may write partially always. We take, it is understood that we are doing partially. So here it will be del Z upon del A. Del A is equal to 0 is equal to X dash minus K upon A square plus 0. So X dash minus K upon A square Y plus 0. And del Z upon del C, this gives 0 is equal to 1 and this is meaningless equation. Therefore, no singular integral exists. Next is general solution. So here we put C is equal to phi A and Z is equal to AX plus K upon AY plus phi A. So we differentiate it partially with respect to A. This gives X minus K upon A square Y plus phi dash A. And if we eliminate in A and B, then we get the required general solution or general integral of the given equation. So next example है, p square plus q square is equal to m square. M is constant. So this is fpq is equal to 0 और ये फॉर्म है, इसका मतलब इसका सॉल्यूशन होगा z इज इक्वल टू ax प्लस बी वाई प्लस सी। और अगर हम यहाँ पर p की जगह a, q की जगह b रखें, एफ ए बी इज a स्क्वायर प्लस बी स्क्वायर इज इक्वल टू एम स्क्वायर। सो बी स्क्वायर इज इक्वल टू m square minus a square under root of this. So we will take positive value only. Now z is equal to ax plus under root or m square minus a square to the power half plus c. तो यहाँ दो आर्बिट्ररी कॉन्स्टेंट्स हैं एंड दो इंडिपेंडेंट वेरिएबल है, तो ये कंप्लीट इंटीग्रल हो गया। अब हमें निकालना है सिंगुलर इंटीग्रल। सिंगुलर के लिए हम डिफरेंशिएट करेंगे कंप्लीट इंटीग्रल विद रिस्पेक्ट टू ए एंड सी। तो सी के जब हम c के रिस्पेक्ट में करते हैं दिस कम्स 0 इज इक्वल टू 1 जो कि मीनिंगलेस है। तो ये नो SI। अगर आप del z अपॉन del a करना चाहते हैं दैट विल कम, जिसकी रिक्वायरमेंट अब नहीं है। 0 इज इक्वल टू x प्लस 1/2 m square minus a square to the power minus half minus 2a into y plus 0, and we can rewrite it. Now general solution. General solution and general integral is c is equal to phi a we substitute करते हैं in complete integral equation. Z is equal to ax plus m square minus a square to the power half y plus phi a. So ये equation a हो गई and del z upon del a is equal to x minus 1/2 m square minus a square to the power minus half into y प्लस फाई डैश ए, ये बी हो गई। सो इन दोनों में से अगर हम एलिमिनेट करें ए को तो हमें रिक्वायर्ड जनरल सॉल्यूशन ऑब्टेन हो जाएगा। एलिमिनेट ए फ्रॉम इक्वेशन ए एंड बी, वी गेट द रिक्वायर्ड जनरल सॉल्यूशन। सो जो नेक्स्ट एग्जांपल्स हैं वो पास्ट ईयर पेपर्स पर बेस्ड हैं। ये क्वेश्चन 1989-1994 का है। फाइंड द कंप्लीट इंटीग्रल ऑफ PQ is equal to x to the power m, y to the power m, z to the power 2l. So the given equation can be rewritten z minus l upon xm yn. So we took this on this side and p is del z upon del x, q is del z upon del y is equal to 1. Further we may write it z minus l upon xm del z upon del x, z minus l yn del z upon del y is equal to 1. Now we take x to the power m dx is equal to capital dx y to the power n dy is equal to dy z minus l dz is equal to this much. So this gives x to the power, and if we integrating x to the power m plus 1 upon m plus 1 is equal to capital X, y to the power n plus 1 upon n plus 1 is equal to capital Y, and z to the power 1 minus l upon 1 minus l is equal to capital Z. Now we want to rewrite this equation 1, and say this is equation 2 and this is equation 3. So we can write down capital Z is also a function of x and y. So we write capital del z upon del x is equal to del z upon del z, because ये तो small z का function है, this is small z and this is capital, so this is small into अब z किसका function है, small x का, और small x किसका function है, capital X का. So this we can write. Now we put values of these. So what happens, this comes del z upon del z, we differentiate it, it comes z to the power minus l, and 1 minus l will cancel out, 1 minus l upon 1 minus l, this will cancel out, and 1 minus l minus 1 gives this much. This is small z, small, into del z upon del x is small 1, into del x upon, from here we find out. So this is, we can get because we can write del x upon del x is equal to dx upon dx, this we can write. So this comes, because here capital X is function of small x only, so del x upon this becomes one upon x to the power m. So here this is 1 upon x to the power m. So this is z minus l upon x to the power m del z upon del x. So we write del z upon del x. Similarly, we can show that del z upon del y is equal to the second term, this one, z to the power minus l upon y to the power n del z upon del y. So we write this equation 1 becomes del z upon del x capital del z upon del y is equal to 1, which is capital P, capital Q is 1. So now this is the form that f of PQ is equal to 0, and its solution will be z is equal to small z, this is a small z, is equal to ax plus by plus c. Now we write b from ab. So if we put in the equation, if we put capital P is equal to a and capital Q is equal to b, then what happens, ab is equal to 1, and this is FAB is equal to 1, So we can write down b is equal to 1 upon a. So we put this value in z, ax, b is 1 upon a, y is plus c. So this is two independent variables and two arbitrary constants. Number of independent variables are equal to number of arbitrary constants a and c. It means it is a complete integral. So we have its solution. Capital Z, this is capital Z is equal to a capital X plus b capital Y plus c, and we put p is equal to a, q is equal to b, and ab is equal to 1. So fab is 1, so b is 1 upon a. Now we put this value of b here, it becomes capital Z is equal to ax plus 1 upon a, y plus c. Now two independent variables and two arbitrary constants. It means it's a complete integral if we put the values of capital Z, capital X and capital Y in this equation. So we do that. So we have x is equal to x to the power m plus 1 upon m plus 1, y is y to the power n plus 1 upon n plus 1, and z is z to the power 1 minus l upon 1 minus l. So we put these values, it becomes z is ax plus 1 upon a, y plus c, a into this is 1 minus l upon 1 minus l is equal to a, x is x m plus 1 upon m plus 1 plus 1 upon a, y is y n plus 1 upon n plus 1 and plus c. So this is complete integral. This example is of 1991. X plus y p plus q whole square plus x minus y p minus q whole square is equal to 1, and we have to find out complete integral. So here also we use new variables as we did in the previous. So we say x square is equal to x plus y, and y square is equal to x minus y, and we know that p is equal to del z upon del x. This can be written as del z upon capital del x into del x upon del x plus del z upon del y into del y upon del x. So from here we can find out del x upon this is, if we differentiate it, this is equation 1, this is equation 2, this is equation 3. So differentiate equation 2. 2x dx is equal to dx, and because it's partial, so del x upon del x will be dx upon dx. So we can write down del x upon del x is equal to 1 upon 2x, and del y upon del x will be 1 upon 2y from this We put these values, so P is equal to del Z upon del X is equal to del Z upon del X into 1 upon 2x plus 1 upon 2y into del Z upon del Y. Similarly, we can write Q is equal to del Z upon del Y, and this is equal to del Z upon del X into del X upon del Y plus del Z upon del Y and del Y upon del Y. And when we do with respect to y, then we get dx upon dy means del x upon del y is equal to 1 upon 2x from equation 2, and del y upon del y, because x minus y is there, so this will be minus 1 upon 2y. So we put these values, we get 1 upon 2x del z upon del x minus 1 upon 2y del z upon del y. We add p plus q is equal to, the second term cancels out, so this is 2 upon 2x del z upon del x, so this is 1 upon x, and when we subtract p minus q, then first term cancels out and second term we will add, and then it becomes 1 upon y, which is capital Y, into del z upon del y. So now we put these values in the equation. So given equation becomes x plus y is x square plus into p plus q whole square, that is 1 upon x square del z upon del x plus y square into 1 upon y square del z upon del y square is equal to 1. Or we can write down p plus q p square plus q square is equal to 1, where p is equal to del z upon del x and q is equal to del z upon del y, and this is the form of fpq is equal to 0. So we can have its solution as z is equal to ax plus by plus c. Z is equal to ax plus by plus c, where a square plus b square, when we put capital P is equal to A and capital Q is B, then we get this equation. So B is equal to 1 minus B square, 1 minus A square under root. We put this value of B in the solution. So Z is equal to AX plus under root 1 minus A square Y plus C, or we can say Z is equal to A under root X plus Y small plus under root. Now a square is as it is, so 1 minus a square, and y is under root x minus y plus c, and this is the required solution. Now we do standard form 2. We call it Clairaut equation also. So first we define what is Clairaut equation. A first order PDE is said to be of Clairaut equation if it can be written in the form z is equal to px plus qy plus fpq. Now we want to solve this equation. For solution we assume let fxyzpq is equal to px plus qy plus fpq minus z. This whole expression is equal to fxyzpq. So from here we can write down Charpit's auxiliary equation. These are dp upon fx plus pfz is equal to dq upon fy plus qfz is equal to dz upon minus p fp minus qfq is equal to dx upon minus fp is equal to dy upon minus fq. Here if we see the first term, they will denominator of first term and denominator of second term, they will become 0, because if we see this equation, and rather this equation where z minus z is there, then what happens when we differentiate it with respect to x, it becomes p dp upon p, and then nothing x is here, then this is minus 1 into p, so this is 0, and dq is fy is q minus q, this is also 0. So first two expressions they give integrating, it gives p is equal to a constant and q is equal to b, this is also, let's say, constant. So substituting these values of p and q in the equation, which is z is equal to ax plus by plus fpq. So this is the complete integral. We get this complete integral. So in another way, you can say that complete integral we have obtained by merely replacing p and q by a and b respectively, and singular and general integrals we have to find out, that we can find out with the usual methods. Sometimes we use change of variables to get the equation in this form. So change P by A and Q by B only to get complete integral, and singular integral and general integral by usual methods. And sometimes we use change of variables, जैसे कि अभी हमने पिछले एग्जाम्पल्स में भी किया. सो अब क्वेश्चंस करते हैं इसके ऊपर. ये एग्जाम्पल 89 का है. कंप्लीट इंटीग्रल फाइंड आउट करना है. पी एक्स प्लस क्यू वाई माइनस जेड होल स्क्वायर इज इक्वल टू 1 प्लस पी स्क्वायर प्लस क्यू स्क्वायर. इसका कंप्लीट इंटीग्रल फाइंड आउट करना है. सो वी रीराइट, एंड दिस गिव्स px plus qy minus z is equal to under root 1 plus p square plus q square. So z is equal to px, and this is plus minus, we can say plus qy. Now this will be minus plus. So we generally use plus value. Now if we see, this is the form which is standard form 2, which says z is equal to px plus qy plus fpq. So fpq is this term and px plus qy are there. So this is a standard form. Now what we do to get the complete integral, we replace p by a and q by b. So z is equal to ax plus by plus under root 1 plus a square plus b square. Now we can rewrite, because if it says that complete integral is ax plus by plus cz, which is equal to a square plus b square plus c square to the power half. अगर इस फॉर्म में शो करना है तब हमें थोड़ा आगे भी काम करना होगा. And we take only positive sign, and we put a is equal to a upon c and b is equal to minus a upon c and b is equal to minus b upon c. If we take this, we can get that. Then it gives z is equal to minus a upon cx minus by upon c plus under root 1 प्लस ए स्क्वायर प्लस बी स्क्वायर प्लस सी स्क्वायर होगा. सो एलसीएम लेंगे, अंडर रूट से बाहर ले लिया, सी स्क्वायर प्लस ए स्क्वायर प्लस बी स्क्वायर. So this gives, we do LCM here, CZ ax minus by on this side, ax plus by is equal to a square plus b square plus c square to the power half. So इस फॉर्म में भी हम इस सॉल्यूशन को लिख सकते हैं, दो we can have here also in the form of a, but rewriting gives this result. So required solution. Next example है complete integral and singular integrals find out करने हैं, and z is equal to px plus qy plus log pq. इस इक्वेशन को हम लिख सकते हैं z इज इक्वल टू पी एक्स प्लस क्यू वाई प्लस लॉग p प्लस लॉग q. और देखा जाए तो ये स्टैंडर्ड फॉर्म 2 है, जो कि पी एक्स प्लस क्यू वाई प्लस एफ पी क्यू है, ये टर्म एफ पी क्यू. सो इसमें हम p को a से रिप्लेस करेंगे और q को b से. So this is ax plus by plus log a plus log b. तो ये तो हो गया कंप्लीट इंटीग्रल. अब हमें सिंगुलर इंटीग्रल फाइंड आउट करना है, तो हम इसे कंप्लीट इंटीग्रल को डिफरेंशिएट करेंगे विद रिस्पेक्ट टू a एंड b पार्शली. सो ये z है, डेल z अपॉन a, डेल z अपॉन डेल a इज 0 एंड ऑन दिस साइड x प्लस 1 अपॉन a, लॉग a का 1 अपॉन a. और जब b के रिस्पेक्ट में किया, सो 0 इज इक्वल टू y प्लस 1 अपॉन b. सो a इज इक्वल टू माइनस 1 अपॉन x एंड b इज इक्वल टू माइनस 1 अपॉन वाई. अब ये a b की वैल्यूज जो हैं हम सब्सटीट्यूट कर देते हैं. सो z इज इक्वल टू माइनस 1, बिकॉज 1 अपॉन एक्स इंटू एक्स कैंसिल आउट हो जाएंगे, सो माइनस 1. सिमिलरली y कैंसिल आउट हो जाएंगे, सो माइनस 1 प्लस लॉग 1 अपॉन एक्स एंड 1 अपॉन वाई. So this will be log 1 upon xy. माइनस साइन बाहर ले लिया. So this becomes z is equal to minus 2 minus log xy. This sign has been changed here and this becomes xy. तो ये हमारा सिंगुलर इंटीग्रल और ये रिक्वायर्ड सॉल्यूशन. टू वाई प्लस जेड क्यू इज इक्वल टू क्यू एक्स पी प्लस वाई क्यू. रीराइट करते हैं इक्वेशन को. टू जेड क्यू इज इक्वल टू एक्स पी क्यू प्लस वाई क्यू स्क्वायर एंड प्लस 2y minus 2y. So this is z is equal to 1 upon 2 px plus y upon 2 into q minus y upon q. Or we can say z is equal to, so this is little bit work you have to do. Remember Without that it's not possible to do it. X square 1 upon 2x del z upon del x. What we do, we take 2x dx is equal to dx, 2y dy is equal to dy, x square is equal to x, y square is equal to y. And then this expression, without remembering or understanding in the examination directly, cannot be done. So plus y square 1 upon 2y del z upon del y minus 1 upon 2y del z upon del y to the power minus 1. So if we see here, z is equal to, same we will be putting. So we use del z upon del x is equal to del z upon del x is small and then del x upon del x capital, and from this expression we find del x upon del x. This is basically dx upon dx also, which is 1 upon 2x, and we put the value and we get this value, del z upon del x is equal to 1 upon 2x del z upon del x, this term. So we write here, so this whole term is del z upon del x, and x square we have taken capital X, so into x and then plus y. Similarly we can write down del z upon del y, and then last term is minus 1 by 2 and that comes, so this comes 1 by 2 del z upon del y to the power minus 1. So this is p x plus qy and minus 1 by 2 q. So this is the standard form 2, and what we do, we replace p by a and q by b. So after replacing this comes z is equal to ax plus by minus 1 upon 2b, and a and b are arbitrary constants, and this is the complete integral of the equation. So this becomes z is equal to ax square plus y square b minus 1 upon 2b. a b are arbitrary constant. Required answer है standard form 3. In this p, q and z are present, and we will find Charpit's equation, and then we will see how to solve it. Then we will write working rule. So standard form 3, p, q and z are present. So equation will be f z p q is equal to 0, and Charpit's auxiliary equations are dp upon fx plus p fz is equal to dq upon fy plus q fz is equal to dz upon minus p fp minus q fq is equal to dx upon minus fp is equal to dy upon minus fq. So x and y are not present, so this won't be there, this won't be there. So this will become dp upon pfz, and this will be dq upon qfz, and rest will be all as it is. These three will be same. So we take first two and integrate, because this will cancel out. So integrating will give log p is equal to log q plus log c. So this gives, we say a log a constant, we are taking a, it gives p is equal to aq, where a is arbitrary constant. So what we do, dz is equal to p dx plus q dy. In this we write aq we convert it into p. So what we do, instead of q we can write it like q is equal to ap also. We don't add it here, we add it here. So we don't use this, we use this a p dx plus ap dy. This gives p dx plus a dy. And then we can write it p d of x plus ay. So dx plus a dy, and a plus x plus au is equal to, let's say, u. So this becomes p du. So p is equal to, this is equal to dz upon du, and q is equal to ap. So this is a dz upon du, and we substitute these values of p and q in, put p and q in equation 1. So this becomes f dz upon du, a dz upon du, and z is equal to 0. And this is an ordinary differential equation of first order. Ordinary differential equation of first order. And we solve this equation. Solve equation A. We get z as a function u, function of u, and complete integral we can obtain then by complete integral, replace u by x plus ay. So this is the solution. Now we can have working rule for solving equations of the form f p q z is equal to 0. So we write down the steps. For step is, we take u is equal to x plus ay. Reverse order we are doing. A is arbitrary constant. Then we replace P and Q by dz upon du and A dz upon du respectively in equation 1. Equation 1 is this, and solve the resulting ODE of first order by usual methods. Third, then we replace u by x plus ay in the solution. Note, sometimes we use change of variables also and convert the equation or reduce the equation in standard form 3 and then solve. And then singular and general solutions we obtain, as we know, by those methods. So this example is of 1991. Find a complete integral of p cube plus q cube minus 3pqz is equal to 0. So steps, as we know, this is the equation fpq z is equal to 0. In this we will put as x plus ay as u. a आर्बिट्रेरी कांस्टेंट है, p को हम रिप्लेस करेंगे dz अपॉन du से, q को a dz अपॉन du से. So this becomes dz upon du cube plus a cube dz upon du cube minus 3 dz upon du a dz upon du into z is equal to 0. So this becomes, these are square, so square will remove this, we cancel out. This is dz upon du, we take common, 1 plus a cube minus 3az is equal to 0. So this equation is now, we separate the variables. So dz upon z and we can write constant 1 plus a cube is equal to 3au is equal to 0. 3au du is equal to 0. 3a du. Now we integrate it. So 1 upon 1 plus a cube log z is equal to 3au plus constant, say b, or we can have u is equal to x plus ay. So 1 plus a cube log z is equal to 3a x plus ay plus b, and this is the required answer. Required solution. Next example is, this was asked in 1996, 1979. Complete integral of z square p square plus q square plus 1 is equal to k square. So first we see this equation is f p q z is equal to 0. It means what we do, we follow the steps. U is equal to x plus ay, a arbitrary constant है, p by, we replace it by dz upon du, q we replace it by a dz upon du. Here if we see, the equation is of the form pqz is equal to 0, and we put u value, p value and q value and get this expression z square dz upon du whole square plus a square dz upon du whole square and plus 1 is equal to k square. So we take common dz upon du whole square, it comes 1 plus a square, and we take rest of the k square upon z square and this term minus z square. So now this is okay, or we rewrite it and separate the variables. So first we write dz upon du, this is equal to 1 upon 1 plus a square to the power half k square minus z square upon z square to the power half. Now we separate the variables. So dz upon k square minus z square to the power half and z square to the power half will be z, and this 1 plus a square plus half is equal to du. So we rewrite it 1 plus a square to the power half k square minus z square to the power minus half into z dz is equal to du. We take k square minus z square is equal to t and we differentiate it. So minus 2z dz is equal to dt. So z dz is dt upon minus 2. So we write here t to the power minus half. This is dt upon minus 2. 1 plus a square to the power half is equal to du. So now we integrate it. It becomes 1 plus a square to the power half minus 2 t to the power half upon 1 by 2 is equal to u plus constant b. Put value of t, it comes 1 plus a square to the power half k square minus z square to the power half. So if we take plus minus when we took under root, then here it is minus, this minus minus will make it plus. So this becomes, we avoid the negative term, we take the positive term, and this comes u plus b. Now we put the value of u. So this is 1 plus a square k square minus z square to the power half is equal to x plus ay plus b. We square both sides, it becomes 1 plus a square k square minus z square is equal to x plus ay plus b whole square, and this is the required complete integral. Next example is find the complete singular and general integrals of p cube plus z cube is equal to 27z. This equation is of standard 3 type. F p q z is equal to 0. We will put u is equal to x plus ay. A is arbitrary constant. Replace p by dz upon du and q by a dz upon du. So this equation becomes dz upon du whole cube and 1 plus a cube, because we take common from here, is equal to 27z. Now we take cube root of this dz upon du, 1 plus a cube to the power 1 by 3 is equal to 3z to the power 1 by 3. We separate the variables. Dz upon 3z to the power 1 by 3, 1 plus a cube to the power 1 by 3 is equal to du. So now we can integrate it. 1 plus a cube to the power 1 by 3 upon 3 z to the power minus 1 by 3 dz is equal to du. Integrating, then we see that we cross multiply by this 2, we got it here, and we put u is equal to x plus ay, and then we do the cube of the expression. We get this required complete integral. And which contains two arbitrary constants a and b. Now we want to find out singular integral. So for singular integral we will differentiate it with respect to a and b partially. So partially with respect to a and b, this complete integral. So this becomes first with respect to a. So 24 x plus ay plus b into y and square of this is equal to 3 a square z square, because the first term will be z square and for that it is 0. And when we do with respect to b, it becomes 24, because here x plus ay plus b whole square, and on this side nothing of b, so it is 0. So we can take under root of this. So this gives x plus ay plus b is equal to 0. And if this is 0, then from this equation we get 3a square z square is equal to 0, means a is 0. And if we put these value, a is equal to 0 and x plus ay plus b is equal to 0 in complete integral, so we get z into 0 is equal to 0. So we get z is also 0. Z is equal to 0 is free from a and b, and when we have z is equal to 0, we can have del z upon del x is equal to 0 and del z upon del y is also 0. So these values, that is z is equal to 0 and this is p, this is q. P is equal to 0, q is equal to 0, these values satisfy the given equation, hence required singular integral is z is equal to 0. Now we have to find out general integral, and for general integral we will put b is equal to phi a, where phi is arbitrary constant. So we put b is equal to phi a. Value of b is equal to phi a in the complete integrals equations, it becomes 8 x plus ay plus phi a. In place of b we have put phi a. Cube is equal to z square 1 plus a cube. Now we differentiate with respect to, partially with respect to a. It gives 24 x plus ay plus phi a whole square into y plus phi dash a is equal to 3a square z square. So we solve the complete integral equation and this equation. For general solution or general integral, we put b is equal to phi a in complete integrals equation. So this gives 8 into x plus ay plus b is phi a cube is equal to z square 1 plus a cube. Now we differentiate partially with respect to a, and it gives 24 x plus ay plus phi a square into, because it's with respect to a, so y plus phi dash a is equal to z square into 3a square. Now if we eliminate a from complete integrals equation and this equation a, we get required general integral. Now we do the standard form 4. So in this the form is that equations form is f1 xp is equal to f2 yq. So here does z does not appear and xp on one side, say left hand side, and yp on one side. This type of equation is there. So we can write down this f x y z pq is equal to f1 xp is equal to f2 xq is yq is equal to 0. So we can write down Charpit's auxiliary equations, and we know that dp upon del f upon del x plus capital plus p del f upon del x is equal to dp dq upon del f upon del y plus q del f upon del y is equal to dz is equal to minus p del f upon del p minus q del f upon del q is equal to dx upon minus f and dy upon minus fq. So now we write in terms of f1 and f2. After differentiating, it becomes dp upon del f1 upon del x. Because there is no term of z, so that term will be 0. P del f upon del z is equal to dq upon minus del f2 upon del y is equal to dz upon minus p del f1 upon del p minus, again then it will become plus del f2 upon del q is equal to dx upon minus del f1 upon del p is equal to dy upon del f2 upon del q. So now we take this and this expression and cross multiply it. It becomes, and we take both the terms on one side, del f1 upon del p into dp plus del f1 upon del x into dx is equal to 0. And if we look at it carefully, f1 is function of x and p, so it's a partial differentiation with p and x, so we can write down this total differentiation df1 is equal to 0. So when we integrate, df1 0 is f1 is equal to a is arbitrary constant. It means f1 xp is equal to f2 yq is equal to a. We can write them separately. f1 xp is equal to a and f2 yq is equal to a. Now we solve these two equations, this and this equation, for p and q. Solving for p and q respectively, we get, means this is for p and this is for q. We get p is equal to f1 xa, let's say this is the value, and q is equal to f2 ya. This is also, we are assuming that this type of function is there, and we substitute these values of p and q in dz. Dz is equal to p dx plus q dy. So this becomes f1 xa dx plus f2 ya dy, and this is dz. Now we integrate and obtain the value of z. Z is equal to integral f1 xa dx plus f2 ya dy plus b. This is constant. So now here two arbitrary constants and two independent variables. So this is complete integral of the given equation. And if we need, we will use change of variable. And singular integral and general integral we can obtain with the usual methods, जैसे कि पीछे किया. So let's do examples based on it. This example is of 1990 CSE. Solve this equation. So we separate the terms. We need f1 x p and f2 qy. So these type of functions we need. So we write py plus q x plus p. We divide it and take terms on this side. So q upon y. So if we cross multiply, we will get this equation. This expression is of form is f xp and this form is f2 qy. Now as we did earlier, we put both sides equal to a. So p upon p plus x is equal to a and minus q upon y is equal to a. And from here we find out p and q. So p is equal to pa plus xa. So p1 minus a is equal to xa. So p is equal to xa upon 1 minus a and q is equal to minus ya. So we put these values in dz is equal to p dx plus q dy, and this comes xa upon 1 minus a dx minus ya dy. So we can integrate it. Integrating, we get z is equal to, this is a upon 1 minus a is constant into x. So this is x square by 2 and minus a y square by 2 plus constant b. So we can write, to make it similar, 2 we can write 2. So 2z is equal to a upon 1 minus a x square minus a y square plus b. A we can take common, or we can leave like this. This is our complete integral because two arbitrary constants and two independent variables. Next question is, this question is of 2001. We have to find out complete integral of PDE 2p square q square plus 3x square y square is equal to 8x square q square x square plus y square. So we rewrite this equation and see the, so we rewrite the equation. It is, we take q square common, 2q square, it is p square, and from right hand side it comes 8x square into x square. So 2q, 4x to the power 4 is equal to x square y square. Then this becomes 8q square minus 3. So we separate the terms. We take x and p terms on one side. So 2q square, we remove this q. P square minus 4x 4 upon x square is equal to 8q square minus 3 into y square upon q square. So this is f1 xp, this is f2 qy or yq. So we got these two expressions. So as we did that, we put these two terms equal to a, but here we will put them equal to 4a square. Any constant we can take. So we write p square minus 4x to the power 4 upon x square is equal to, we are taking 8a square, so this 2 is gone. So 8a square, so this becomes 4. Now second term we write y square 8q square minus 3 upon q square is equal to 8a square. Now we find values of p and q. A is arbitrary constant, that is well known. So p square is equal to 4x4 plus 4a square x square. This comes 4x square x square plus a square. So p is under root of this. This is 2x x square plus a square to the power half. And q square we find out y square 8q square minus 3y square is equal to 8a square q square So we take 8q square common. So a square minus y square is equal to minus 3y square, or we can write down 8k square y square minus a square is equal to 3y square. So q square is 3 by 8 y square upon y square minus a square. So under root of this 3 by 8 means 3. So this is 3 by 8 to the power half y upon y square minus a square to the power half. We got p and q. Now we write value of p and q in dz. dz is equal to p dx plus q dy. So this is 2x x square plus a square to the power half plus 3 by 8 to the power half y upon y square minus a square to the power half dy. So now we have to integrate it. Integrating, we get z is equal to integral 2x x square plus a square to the power half dx plus integral 3 by 8 to the power 1 by 2 y dy upon y square minus a square to the power half. So we do x square plus a square is equal to, say, t. It means 2x dx is equal to dt, and we have 2x dx is dt. So this becomes integral t to the power half dt. And now we come to this one, y square minus a square, we say u. So 2y dy is equal to du. And we have from here, we can take 2 from here, it becomes 3 upon 2 to the power 1 by 2. This is 1 upon 2 because 4 under root is 2 y dy upon y square minus a square to the power half. So we write this one. It means y dy is equal to du upon 2. So this can be 3 upon 2 to the power half. Y dy is, we write it u to the power minus half. Y dy is du upon 2. So du upon 4. So this becomes 3 by 2 to the power half y dy upon 2. This becomes u to the power minus half, and we have taken this 2 into, so du upon 2 is du upon 4 plus constant b. Now we integrate it. This is what we have to integrate. We have written these terms outside, and the integration is this. So z is equal to t to the power 3 by 2 3 2 plus 3 by 2 to the power half into 1 by 4 u to the power minus half. So u to the power plus half and plus half plus b. Now we put values of t and u. So 2 by 3 t is x square plus a square. X square plus a square to the power 3 by 2. 3 by 2 to the power half into 1 by 4. So this becomes 2. So 1 by 2, and u to the power half is y square minus a square to the power half plus b. This is the value of z. And here we see a and b, these two are arbitrary constants and two variables, independent variables. So we got the complete integral, required complete integral. Now all the 4 special standard forms have been completed. So in next video we will see the Jacobi method and Jacobi method for solving non-linear first order partial differential equation in 2 independent variables also, and Cauchy's method of characteristics for solving non-linear partial differential equations, and based on these methods we will do a few examples also. Thank you.